Hello everyone and welcome to Networktalk. This is Sundar. Today we are going to talk about CCNA 200-301 Networking Fundamental Switching Part 2. Today's agenda is talking about switch types, switch tables, layer 2 and layer 3 switch difference. Okay. Types of switches: KVM switch, managed switch, unmanaged switch, smart switch, and then last PoE switch. We can talk about each switch in coming up sessions. Okay. First one is KVM switch. If you guessed that KVM stands for keyboard, video and mouse, you would be correct. That's this switch separately using for keyboard, video and mouse connection only. This type of switch is used to connect a keyboard, mouse or monitor to multiple computers. These switches are often used to control groups of servers while saving desktop space by eliminating cables. A KVM switch is an ideal interface for a single user that needs to control the functions of multiple computers from a single console. These devices can often be performed with keypad hotkeys that let you easily switch between PCs. This is the diagram for the KVM switch. Normally in data center or in NOC operation centers, on single server having multiple like 10 servers has been mounted in single rack. So that time we'll use the KVM switch to connect single monitor, single keyboard and mouse for entire 10 servers. So we can use the hotkeys to switch the servers to 1, 2, 3 and then we can easily go into the physical of the server monitor. It will reduce the space of the networking rack itself, so that there itself we are using KVM switches. Managed switches. A managed switch is exactly what it sounds like, a switch that requires some oversight by a network administrator. This type of switch gives you total control over the traffic accessing your network while allowing you to custom configure each Ethernet port so you get maximum efficiency over data transfers on the network. Many administrators use managed switches to create virtual local area networks, VLANs, which allow you to further segment your network and control the traffic burden for each type of connected devices. Another benefits of managed switch setup is that the majority of managed switches are designed with spanning tree protocol. In spanning tree is the big topic. We can take separate class for the spanning tree, how it's working, what are the types of spanning trees there. We can take it the later session. This enables administrator to perform quality of service duties and access the switch remotely to make adjustments without having to be in the same physical location as a switch. This is the diagram for the switch. So managed switch is like what means network administrator can configure VLAN, some other functionalities like features of the some other features we can configure in that switch, and then we can use some particular IP address to manage the device in remotely. So it will be called managed switch. Okay. Unmanaged switch. That name itself you will find unmanaged. So let me check. Unmanaged switches are generally made as plug and play devices and require little to no special installation beyond an Ethernet cable. So this unmanaged switch is like plug and play only. If you need, if administrator no need to configure anything, it's pre-configured. Just you connect the device Ethernet cable to the switch, it will be working fine. The setup of this type of switch relies on auto negotiation between Ethernet devices to enable communication between them. The switch will automatically determine the best data rate to use. Switching between full duplex mode or half duplex mode. Smart switch. Another popular type of switch in networking is the smart switch, also referred to as an intelligent switch. These devices are a type of managed switch with only a selected number of options for management. Rather than providing the full management functionality of a managed switch, a smart switch may only provide functionality to configure a handful of settings like VLANs or duplex modes. PoE switch or injector. PoE stands for Power over Ethernet. A PoE switch distributes power over the network to different devices. This means any device on the network, from PCs to IP cameras and smart lighting systems, can function without the need to be near an AC access point or router, because the PoE switch sends both data and power to the connected devices. Like camera, then organizations they are using camera devices and smart lighting that will connected to the PoE switch, so that power supply and the data both has been sent from the PoE switch itself. Okay, this is the PoE switch. Switching table. Packets or frames are forwarded by looking up the destination MAC address in the switching table. The frame is sent out the corresponding switch port. The switching table contains MAC addresses and the switch ports on which they were LAN or statically configured. The switching table entries are normally dynamically LANed as packet flow. Entries can also be statically defined. CAM table. On Cisco switches, the MAC address table is stored in content addressable memory, CAM memory. So it's called CAM table also in Cisco's. RAM queries a specific memory address and then returns the data or content stored at that address location. Okay, RAM is specific memory address and then it's return the output result to the same address location. In CAM operates essentially in the reverse. It does not require that memory address be provided. Instead, CAM queries for the desired content and then return all matching results, including any associated content. CAM is significantly faster than RAM, as it searches the entire memory content in one cycle instead of a single address at a time. However, RAM is more expensive than RAM. Switching queues, how the switch queues will work and how it's land MAC address from the packet. Here you can see the same sample diagram, like host A, host B connected to the switch, host A connected to port 1 switch and host B connected to port 2 switch. Okay, the switch receives a frame on port 1 from host A designated for host B. Okay, here, so this is the ingress port for the switch. Okay, port 1 is the data receiving place, so it's called ingress port. The frame is placed in port 1's ingress queue, so it's in ingress queue. The switch performs a lookup on the destination hardware address. So it receives the ingress port and then it's going to the switching place. So switch checking the MAC address table and look up the destination hardware address. In this case, it's a host B hardware address. Okay, so the switch determines that the appropriate destination port for host B is port 2. If the switch MAC address, switch MAC table already having the host B MAC address, means it will store the port number itself. So port 2 is the egress port, so the frame is placed in port 2's egress queue. Okay, if the switch had no knowledge about host B, if the table MAC table, so host B is not available, means the frame would be placed in the egress queue of all ports except that originating port 1. If that switch have 48 port, it will send the queue to all the 47, not to the port 1 except. Okay, and this floated to the entire network. Layer 2 versus layer 3 switch. This is called the open OSI layer. Later session we can talk about this one, because it will have, we need to talk about it much more. This is the heart of network communications, so we will talk each layer functionality and how it's working, and network engineer need to check what kind of layers and how we can troubleshoot the layer issues. In coming up sessions we will take these classes. So now we are talking about layer 2 and layer 3 switch. You can see layer 1 is physical layer, layer 2 is data link layer, layer 3 is network layer, 4 is transport layer, 5 is session layer, 6 is presentation layer, 7 is application layer. So here we are talking about layer 2 and layer 3 switching. So layer 2 switch only deals with MAC addresses and cares no IP address. In this verse it's doing only for MAC only. It's not, if the data having the IP address also, it will not checking the IP address, only learning the MAC address only. In layer 3 switch is different. It's checking MAC address as well as if the data having the IP address, it will check both the things. So it's called layer 3 switch. Okay, In router is working as the layer 3 features combined WAN technology, because router is working in layer 3 only. It will be routing two different networks, that is called its router. Okay, layer 2 switch. Layer 2 switch and layer 3 switch difference: operates on the layer 2 data link layer of OSI model, operate on layer 3 network layer of OSI model, send frames to destination on the basis of MAC address, route packet with help of IP address, work with MAC address only, can perform functioning of both layer 2 and layer 3 switch, used to reduce traffic on local network, mostly used to implement VLAN virtual local area network, quite fast as they do not look up at the layer 3 portion of the data packets, takes time to examine data packets before sending them to their destination. It has a single broadcast domain. It has multiple broadcast domain. Can communicate within a network only. Can communicate within or outside network as well as. Simply, layer 2 switch, it's not checking layer 3 information. It's only work with MAC address only. Layer 3 switch, it's to the both, can perform functioning of both layer 2 as well as layer 3. Layer 2 switch having single broadcast domain, like single same network broadcast domains. In layer 3 switch has multiple broadcast domain, like it's communicating to different VLANs. So normally we are using VLAN creation purpose only, we are using layer 3 switches. Okay, thanks to everyone, thanks for watching.